Welcome, and thank you for attending today's crane safety webinar about how to choose an operator training simulator. My name is Mike Larson, editor of Crane Hotline, and your host for today's conference. If you have follow-up questions, comments, ideas, or suggestions after today's event, please feel free to contact me at the end of the presentation. Today's sponsor is CM Labs Simulations. CM Labs builds simulation-based solutions that help clients design advanced equipment and prepare for skilled operations. Its Vortex Studio software lets clients experience their product vision before it's a reality and train crews for safe and efficient operations before they step on a real job site. For more information about CM Labs, visit www.cm-labs.com. When you're buying new technology, it's easy to get overwhelmed by product specs and sales information. This webinar will give you the knowledge you need to conduct true apples-to-apples comparisons of simulators, including the 10 questions you should ask before buying. At the end of the webinar, we will hold a question and answer session. If you have questions for our presenters, please type them into the chat box on your screen at any time during the presentation. This presentation is being recorded and can be accessed this week on www.cranehotline.com. I'll post the address at the end of the presentation. Also, CM Labs will email a checklist and a white paper sometime later next week. Our speaker today is Drew Carruthers, Product Manager for Vortex Simulators. Drew, the mic is yours.
Thank you. Just wanted to quickly introduce myself, and I'll start my presentation here. I've been working in the simulation-based training business for 18 years, and for 18 years now, 8 years in vehicle design and 10 years in technical training of simulators. Now I'm the product manager of construction equipment here at CM Labs. So I'll just start the presentation here. First of all, CM Labs, the goal today is really to provide you guys with objective information. It's not to really be a sales pitch. I don't want it to come off this way. Up front, we do make simulators, and of course, I have an opinion about simulators, but it's really just to make sure that everyone has all the information and tools they need, because I do believe in simulation, that if you have the information and you share about it, then the entire simulation industry will benefit from this. So it's really to make sure that people are making informed decisions. I'm going to go over some kind of questions that you should be asking yourself when you're looking into simulation, and perhaps more importantly, how to assess your needs. I'll finish up with a question and answer session, and I'll do as best I can to respond to all those. But any questions I don't get to, certainly feel free to email me. So CM Labs is a simulation-based training solutions provider in Montreal. We have construction and port equipment that we design for, and we have over 1,000 simulators worldwide. So starting with why should you even consider simulation? So what simulation does is it maximizes your training resources. The real equipment is precious, and it's difficult to get at. The simulators, what it does is it gives you concentrated seat time. It gives your students, your trainees, a chance to experience the equipment much more. It allows the trainees to be self-paced. Equipment is dangerous and requires supervision, and it requires skilled operators. Well, with simulation, you can just have them go off and learn on their own, and that will certainly benefit their learning curve. And with simulation, you can get yourself into challenging such conditions repeatedly, consistently, and push really the limits of the simulators of the student skill set. You know, wind, nighttime, or equipment failure. You can experience a year's worth of operation inside an hour. With simulators, they're based off computers, so everything is recorded. Everyone trains under exactly the same conditions. You can measure the results in a very quantitative way, in a very objective way. And there's lots of tools that you can use to deconstruct behaviors and attempt to find patterns, both good and bad, really, that can help you assess the student's operations at that time. Certainly, simulation reduces costs of operation. Equipment now is running at 10 to 14 gallons an hour. The maintenance costs, the incidents and the insurance, I mean, those are obvious things. But what also simulation does is it allows a one-to-many experience. Any operators out there have certainly had the experience of piling in 8 students into a cab to show them some panel. Well, and it's noisy and not everyone can see. Well, with simulation, you can do that in a quiet environment, and it's certainly a lot more conducive to learning. So simulation also really gives you a chance to discover the next generation. There's an attrition out there. The older generation is retiring, and we need to attract younger students into it. The machines are becoming more and more complex. We need them in our industry. We need to convince these guys that there's a future inside heavy equipment operation, and we need their skills. They're much, much more used to computers, and with machines becoming more complex, we're going to need those skill sets. And simulation can get somebody and have an experience on a machine at a trade show and very quickly assess and find that little diamond in the rough of an operator and tell them, come, the industry will take care of you. There's a good future for you here. And you can introduce novices to best practices. So the idea is that you can get them in a very comfortable, quiet environment without the real fear that they're going to be destroying something. So really, like any tool, it's how it's applied. It's how simulation will benefit you guys. Some people will use it to check out operators, increase throughput for schools, or it's really how you use it is really up to your imagination. So different approaches that we've seen out there is just simply using training simulators for inclement weather. When it's too windy to be operating cranes, get them on the simulators. We've also seen people using it to assess the trainees' readiness, so really to check them out, to really put them through their paces. We've seen some people alternate simulator time and equipment time. So what that does is it allows the use of your equipment to be maximized, and you have more experience on the equipment, on experiencing the equipment. Out in industry, we talk to people who are the jack of all trades out there, the guys who say, I am the crane operator, but I only use it once every 2 or 3 months. I'm a little bit frightened about the next time I do it. So what a simulator can do is to boost their confidence again. And certainly if there's an incident, to get them back up on that horse and to be working with the equipment. So how are you going to fit this into your training? So there's a number of services that are available to you through the simulator provider to help you integrate training. It is a training tool, and it needs to be integrated into your training program. So at the very base level, you'll get your instructors trained to how to use and how to maximize this training tool. There's certainly the next level, which is basically taking your existing program and finding out how are you going to match up your learning objectives. How are you going to understand how training simulators can really work with your established training program, and all the way to fully assisting in building a program from scratch. The training simulator provider should be able to provide the service for you to help you really understand what you're getting into. So I want to take a quick look at some of the examples of some of what other people are doing. Our friends out in Alberta, their state, have a great training school. They purchase simulators to train the students in a classroom to increase their class size and to really objectively assess. I mean, there's no telling what weather will happen and what different instructors will look for, and it's really to really baseline the students. And it's interesting, and it's high tech. It attracts students to your program, and they've had a very, very successful program out there. Del Mar College in Texas there, they've used it, they put it in a mobile training solution. So they take the classroom to the students, and they are able to reach people who don't have time to travel to their headquarters. And they do a very effective signaler station there. So that's team-based training. One student will be on a crane simulator, and one student will be signaling that person. So it's really involving and engaging the maximum number of trainees as possible. Mammoet, we did a project for Mammoet where we integrated their computers into our simulation. The crane that you see on the screen there, there's not that many of them in the world. You can't just find and sit on one. The touchscreen interface has 200 pages. It's a very expensive piece of equipment just to exist. So we do it in a simulation, and these guys are really about risk mitigation, getting people experience on the crane when the crane isn't available. So, simulator. What constitutes a simulator? What are the pieces of the simulator, and what should you really look for in those pieces? The first thing is motion platform. It's the most obvious one. It's when it moves. The simulation moves. If you ask an operator, they're using all their cues, their ears, their nose, the seat of their pants to feel the equipment. What a motion platform does is facilitate that. I used to work in flight simulation where they had these platforms that you see on the right-hand side here. Those have what's called 6 degrees of freedom. You can move any direction in space, forward, backwards, up, down, left, right. Those are expensive, and those simulators start at $8 million. That's certainly not what we have in our industry, but that is the top of the line. That's what extreme motion simulation would look like. We've done a lot of different motion solutions, and we've settled on 2 or 3 that seem to work best. The most important motions are pitch and roll. The heave one has a little value, but when you add heave to a motion platform, it actually doubles the hardware cost because you're doubling the actuators that you need. So we've settled on 2 degrees of freedom. There's certainly solutions out there with 3 degrees of freedom, but we find that the reaction to price point is best with basically just feeling the pitch and the roll. Some simulators out there will have surge forwards and backwards, but again, you're really falling in love with the idea of motion, and you're just needing a sensory cue. You don't need to replicate every single minor motion. The range of motion is quite important too. What you want to make sure is that you are getting the range of motion that you want, and more than just a bump. You really want to be leaning. If you're an excavator operator and you're on a side, you want to feel that you're leaning to the side. So really, the range of motion is something that you guys should be paying attention to too. Let's back it up here. So into display technologies. So there's a lot of display technologies out there. We've experimented in all of them. It ranges from dome projections to virtual reality headsets to flat panel display technologies. So I just wanted to quickly talk about each one of these in turn. Dome projections are expensive. The projectors are expensive. The maintenance is expensive. The repair is expensive, but they are beautiful. They are very well used in flight simulation. We've done them in construction simulation, but the upfront cost is something that is really not something that goes to the masses, and they are prone to failure. And it's not well known, but they are very low resolution, so you're not really getting a lot of bang for your buck for the dome projections. Virtual reality is out there. It's getting a lot of buzz for sure with Facebook. It's got some really interesting applications to it. For certainly maintenance, you see the guy here looking at a computer in virtual reality for experiencing that 3D object in space. They're very effective for this. They are, of all the latest technologies, have the lowest resolution by nature of where they are close to your eye. VR in its current form has been out for about 5 years now. It's not quite there yet for operator training. If you think about when touchscreen phones came out, 5 years after touchscreen phones came out, everybody had one. VR has been out for 5 years, and that surprises a lot of people that it hasn't caught on yet. And there's a couple of reasons for that. We've been playing for VR for 2 years now. We've been doing demos with it. When we put it side by side to a screen solution, the overwhelming response is that the screen solution is a better choice. Some of the other issues that I have with it, it's that it isn't conducive to group learning. There's no interactions. We believe that this is a training tool, so it's an interaction with your peers. It's an interaction with your instructor, and you're challenging ideas. VR kills all this. You block your eyes, you block your ears, and you're just immersed into what the game thinks that you should be going towards. The idea that there's a sickness, not everyone does get sick, but certainly there is a lot of studies on VR sickness. That concerns me. If you were to purchase into virtual reality and you have a student who gets sick on it, what do you do with your training program? You're certainly going to be needing to find different ways for that person to experience the simulation. And the Army doesn't allow operators to operate vehicles 24 hours after using VR because of something called GTP, which is game transfer phenomenon. If you're familiar with Tetris, that's certainly something that is manifested in Tetris, where VR will facilitate hallucination of objects that are related to the experience. So in Tetris, you'd see the blocks when you close your eyes, and virtual reality has been shown to trigger that. So it's something that we have our eye on. We certainly are able to integrate into, but it's not something that we offer because it's not quite there yet. So flat slating technologies come in many, many sizes. The one that you're looking at there is 12 screens. Traditionally, 1, 2, 3, 4 is what you're going to see. We went with this path because it's the graphics. It's the highest resolution that you can get on the screens. And we believe that simulation should be experienced over time. You're going to get a work shift length exercise, which is 1, 2, 3, 4 hours. You can only do that in front of screens without a lot of fatigue. And the interaction. So the trainee can come over, he can ride along with you, he can experience with you, point out ideas, and screens with the open concept really facilitates that interaction, which is really what we are looking for in technology. So screens can come in many different shapes and sizes. In general, a vertical screen is good for cranes where you want to see your boom tip and your landing points, and horizontal is good for earth moving where you want to check your blind spots as you're turning into them. So something that you might want to consider is where is your field of view for your visual solution. So ultimately, the visual solution is very interesting, and it's certainly a great idea for marketing, but really what we're pushing is the idea that the training content is much more important. The training content will really help your trainees transfer your skills into the real world. You're going to get them to feel the machine and how it reacts, and you really want to try to make sure that people aren't getting overconfident with their experience inside simulation, that they are now an equipment operator. So with high-grade simulation, the simulator will the trainee will feel the simulator dig in when you are pushing too much dirt, or they'll get the idea when you're picking up a load, it's going to slightly bend the boom and you'll feel the cab tilt forward. That is really important. You want these people to be able to say, I have a healthy respect for the equipment, and when I get on the real equipment, I understand that this thing is dynamic and moves around a lot. So that's quite important that the machine behaves the way it does in the real world. After the machine, you're going to want a simulator that really integrates into what your values are. A lot of the training goes into the idea of, are you experiencing what they experience on the real work site? Are the challenges that you are going to face in the work site, have you had a chance to have them exposed to that inside the simulation, the emergency weather and the faults and the hydraulic brakes? And the idea of team-based training, anyone who's been on a job site knows that the signaler is the conductor of the work site. Is that replicated in reality? Do you have a chance for your students to develop a bond and to develop what it means to be controlling the environment? So team-based training is quite important. Operator controls. This is how you touch the equipment. And the gaming controls are good to learn that up is up and down is down, but what you really want to do is to experience as much of reality as you can. So touching real equipment controls gives the students a sense of, okay, this is how it feels, this is how the controls react. So when you get onto the real equipment, that it feels the same way, that the controls have the same type of stiffness to it. So real controls are quite important for basically the soft idea of how you touch the equipment. A lot of simulations have the idea of controls that you can swap out, so one base can represent many different pieces of equipment. It's a really interesting idea. So you might want to ask yourself, how difficult is it to swap the controls out? Can one person be doing it? Are there any wires hanging on the ground where someone could trip? These things are quite important, that you want to make sure that it's a safe environment. Looking at the equipment, does it look robust to you? If you drop it, is it going to break? Simulation creates a very stressful situation where novice students can react very forcefully. Hit the equipment, kick the equipment. Is the simulator going to be able to just stand up over years of abuse, really? And finally, choosing a simulator vendor is quite important. A couple of questions that you might want to ask yourself is this their core business? Are you going to be a guinea pig in their solution? Have they been doing it for a while? Do they have a deep catalog of equipment that you can benefit from? But the best way of doing it is contact their existing clients. Ask them, how's it going? What have been the pain points? What has been the benefits of this? And really do your homework and understand how this thing has existed in the field. And certainly understand and ask questions. Are they going to be there for you to help you figure this out? Are they going to be there for you to figure out how to integrate this into your training program? So now I've come to the last section here. I wanted to just kind of wrap this up with 10 questions that you should be asking yourself when we are going to go look for a simulation solution. So the first is, what are your goals? Why are you considering simulation? If you don't have a clear idea of how simulators will fit into your training program, your investment's not going to be a success. You're going to ask for help from other users and really define what you want to achieve with this and create a conversation. What are you going to measure? Defining what the indicators you will be used to gauge success will allow you to adjust your simulator training over time. How can you maximize this tool to the best of your abilities? Do our experienced operators agree that the simulation is accurate enough to transfer real skills? So the idea of the machine fidelity, get a trusted operator on there. Get them to say, does this give any false sense of confidence? Will a novice operator get on there, get an easy win and say, I got this? What we're hoping that simulation evolves into the idea of transferring humility and a respect for the machine. So get your operator on there and put it through its paces. Ask the difficult questions when these things are going to be simulated well. Does the simulator take the training from the beginner to the real work site? So are you buying a simulator for the first 8 hours where they can learn that up is up and down is down, the control familiarization, or are you going way into skills acquisition, to machine understanding? The fifth question that you should ask is, can your instructors introduce fault or emergency situations? The idea of simulators in aviation and trains and all the industries that have deeply embedded simulation programs is the idea that you can put people in unfamiliar, uncomfortable, stressful situations. Can the simulator that you're looking at do that? How many machines can you work on? So when you buy a simulator, how many can you upgrade into? Does it have cranes and earth moving, multiple types of crane? Does it match or come close to the equipment that you have in the yard? Because certainly the more that you can use simulation, the more it'll benefit your actual existing equipment. Does the training exercise come with a lifting work site? So the idea that the majority of a crane operator or even heavy equipment operator is done in preparation, that's important. What comes with your training exercise as far as lift plans and load charts? Do they understand that that's what you do first, that you don't just get onto the equipment and you start operating? You need a program that understands and can facilitate that. Do the trainees get that kind of easy win thing? Again, this is not a game. It's a training tool, and it's not designed for good feelings. You need to cultivate proper attitudes and not a false sense of confidence. So ask yourself, is this just meant to give a smile? What reporting is available? So after they experience the simulation, what can you do to deconstruct what just happened? Does the simulator provide any indicator of the competency? Is the score that they receive at the end transparent to the trainee? How do they arrive at that percentage? Can you change how a student was scored to reflect your safety values? Those are really important things. You don't want to be having somebody else dictate what your training program should and shouldn't be measuring. You should have that control. And finally, is it robust enough to last 5 years? Everyone who has a phone or a computer knows that technology is evolving very quickly. Will your simulator be around in 5 years to still be able to use? These are investments. These aren't things that are disposable. So is the simulator that you're looking at, are there examples of this thing being in the field for a long time? Can you still get upgrades after 2 or 3 or 4 years? Is it future-proofed is really what I'm trying to get at here. So finally, go out and try them. With a trusted operator, it's for your benefit. Try it for an extended period of time. Go back, reflect on what you experienced, and go try it again. It's a big investment, so we really recommend spending time with this and understanding how this benefits and if this has a very interesting feeling up front, but then it really turns out to be quite a shallow investment? Or is this something that can grow with your knowledge and grow with your training program? I appreciate everyone's attendance. I'm pleasantly surprised with the number of people who signed on to listen to me talk. And now would be a good time for a question and answer, but I thank you for your attention.
Thank you, Drew. We will take the questions now. The first one is, what percentage of training time can you replace on the real equipment by using simulation?
That's a great question. It's something that it speaks to the return on investment and what benefit do you get once you get this. With our partners, our training schools, we've seen 1 week of savings times on a 6-week program. So where traditionally they had 6 weeks to execute the program with a simulation-based training, they found 1 week of extra time where they're able to go deeper into knowledge or have more experience with the crane. So what we're seeing is about 1 week for every 6 weeks of training.
Interesting. The second question, can simulations be customized to specific scenarios relevant to an organization?
Certainly. Again, it comes down to cost. Certain industries, like the port industry, really want to have their environment, their line markings. In the construction industry, it's a little bit more generic, but if you want your environment, your equipment, it is absolutely possible. We work with regulatory agencies who have, in North America and in Europe too, who have very specific tasks to very specific tolerances that the trainee must achieve. So what we do is design a scenario that they can practice this and be evaluated on this before going on the real equipment and being checked out. So it's really, it's quite easy, yes.
Okay. Is it possible to train as a team with simulators?
Yeah. As mentioned there's the idea of a signaler where you're dropping a person into the environment and they are giving hand signals to a crane operator. That's certainly been around for quite a while. But also the idea of putting 2 pieces of equipment where you have 2 simulators side by side as a crane lifting up the same pipe, so that if operator number 1 behaves badly and pulls on it, that pull is felt in the other simulator. Tandem operations. That's been around for a while too, and it's something that's quite interesting. On the earth moving side, certainly too, there's a lot of simulations that can have 2 pieces of earth moving equipment in the same environment. So it's quite exciting times for that field, yeah.
Okay. Is training available for excavators, loaders, and other heavy equipment?
Yes, I've talked a lot about cranes, but certainly earth moving has a lot of really interesting simulators into it. Excavators, front loaders, backhoes, graders, and dozers. Graders are quite interesting. They are a type of equipment that isn't intuitive, it isn't obvious, and is terrifying. Simulators have been around for quite a while for that one. The more recent ones will properly simulate the amount of fuel consumed, properly simulate the amount of soil. So when you dig too deep, you stall the equipment, that the simulator goes into the stall protection. These simulators are being checked out now by OEMs, by the actual equipment manufacturers. We've worked with Potin and John Deere and Liebherr with their operators to tune the simulators so that it feels correctly as the real equipment. And so really right now, the earth moving is an exciting place for that, because a lot of high fidelity simulation is coming into that earth moving side.
Okay. Is today's technology sufficient to run a physically accurate simulation without large, expensive, specialized hardware?
Yes, now it is. With any technology, you're blessed with early adopters, with people who believe in the technology and will pay for it. Simulation now is beyond that. With the flat screen technology, those are very common and off the shelf, very stable. Computers are very, very powerful now. Laptops, you can run entire simulations off a laptop now. It is the accuracy of the simulation right now is only limited by the software, not by the hardware. So there's a lot of off-the-shelf hardware that can run very high engineering grade simulation on very small footprints.
Okay. Do you see VR as having a future in construction training?
Right now, no, I don't. I think that it's interesting. The VR is interesting, and it has a lot of really interesting upfront applications. Your experience with VR often is a very quick hit. You feel you're on a roller coaster. You feel like you're very high, so you get a sense of vertigo, and that's wonderful for it. It's not quite there yet. It isn't. The goggles are evolving. The VR goggles are evolving so quickly that the ones that you buy now will be obsolete in 6 months, and they won't be able to run the latest software. So we need to wait for that technology to mature a little bit more before going into it. We have our eye on it. We are working with it. We've integrated into it. When it makes sense, we would definitely integrate into VR on a commercial side. But I really think that even Oculus, the biggest manufacturer for these ones, say that really large-scale adoption is about 3 or 4 years away. So we're going to keep our eye on it, and I think that there'll be a different technology that overtakes that. Augmented reality certainly has some really interesting applications and doesn't have the hygiene and vertigo issues that VR has. So no, the VR has had a spike, but it's been out for almost 5 years now, and if it were going to take off, it would have done that by now.
Okay, thank you. I guess that ends today's webinar. Thank you, Drew, for your insights. And again, CM Labs will send out a checklist and a white paper next week by email to all attendees. Thank you.
Thank you, everyone.